Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Chakani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So in our present series of database management systems, we have seen some preliminary lectures in which we have understood about the basics of DBMS, and today's agenda is representation of DBMS schema and query languages. Now DBMS schema is actually we can say a term which is familiar to us, and we have seen what actually a schema is in our previous lectures. So in previous lecture we have seen that a schema is, we can say, an overall structure of the database. Now considering today's agenda, we are talking about what actually what is going to be the representation scheme of this schema. So this representation scheme we know this representation scheme as schema diagram. So basically a database schema along with the primary key and the foreign key dependencies can be depicted by schema diagram. So in a schema diagram, we are going to represent our database schema along with the primary key and the foreign key, and the concept of primary key and the foreign key is also covered in our last lecture. So in this schema diagram, basically what are we going to do? I have told you about relational representation, about relational representation of the database, in which your each and every relation is depicted in the form of a table. So here in the schema diagram, each relation appears as a box with the relation name at the top. So what are we going to do? Corresponding to each and every table, we are going to take a particular box, and on top of that box, the name of that particular relation, the name of that particular table is to be written. Now what about attributes? Attributes as in what columns we are having. So all the attributes are listed inside the box, and primary key attributes or your primary key you can say column is basically underlined. So in this schema diagram we will be taking a box with the name on its top, name of all the columns in the name of all the columns, or we can say attributes or fields, whatever you can say, it's one and the same. So the attributes are listed inside the box, and the primary key is being shown with the help of an underline. Now in the schema diagram, I have told you that along with the schema we are going to represent primary key as well as foreign key. So primary key is getting underlined. What about foreign key? So foreign key is actually, you understand that it is a dependency from one particular table to another particular table. So for example, one particular table is having a primary key which is being taken into another we can say table or relation. So that particular primary key in another table named it will be taken as foreign key. So foreign key dependencies are we can say shown in the schema diagram with the help of an arrow from the foreign key attribute of the referencing relation to the primary key of the reference relation. So there will be a arrow from foreign key to the primary key. So primary key is actually in the referenced relation where it originally belongs to, and the foreign key is present in the referencing relation. So from referenced to from referencing to referenced, from foreign to key to primary key. We will be seeing this with the help of an diagram also. Apart from this foreign key and primary key, if we talk about referential integrity constraints, these referential integrity constraints are not shown explicitly in these schema diagrams. So in the schema diagrams we are going to cover the relation, the name of the relation, the attributes, the primary key thing, and also the foreign key. So for example, we have a let's say university database in which there is a table which is being named as classroom, and it is having three attributes which are building, room number and capacity, where building and room number are taken as joint primary key. Similarly, we have the department table in which the department name, building and budget are the attributes and department name is the primary key. Now, how I am saying it's the primary key? Because this is the underlined attribute, and this is just a way of representation in the form of a text. Soon we will be looking at the representation in the form of in the graphical form also. Now coming to the course relation on the course table, it is having course ID, title, department name and credits as its columns, as its we can say fields, where course ID is the primary key. Similarly, we have instructor, where the ID, basically instructor ID we can say, name, department name and salary are there as the columns in which ID is your primary key. In a section table we have course ID, section ID, semester, year, a combination of all four as primary key, and apart from this the building, room number and time slot ID is our other fields or other attributes which are available. Then in the similar database, let's say we have one relationship, or we can say one table. As of now we can count it as a table. Actually it is a table in the form of entity. So where it is named as teachers, ID, course ID, SEC ID which is the section ID, then semester and year. All attributes are taken as the primary key. Then student ID along with its ID which is the primary key, it is having name, department, total credits. Then there is a relationship table which is takes ID, course ID, section ID, then semester and year as the primary key and grade. Advisors, so SID and IID is the we can say are the fields where SID is the primary key. Similarly, time slot ID, day, start time and end time are the fields where time slot ID, day and start time are the primary keys. Similarly, a table of a relation of prerequisites where course ID and prerequisite ID both are making a primary key. So this was way of representation in the form of a text, that we are going to write the name of the relation and within the bracket we are going to write the name of all the attributes where your primary key is to be underlined. Now in this way we don't have any way to represent a foreign key dependency, but when we convert this into a form of a schema diagram, which is actually a graphical diagram, so yes, we are going to show foreign key dependencies also. So corresponding to this whole database which is having many tables as is teachers, student, takes, advisor, time slot and so on and so forth, here is a we can say graphical diagram. If you can see this on the screen, so we have many tables. In each and every table or each and every relation is being depicted with the help of a rectangular box on which on top of it there is the name which is presently shown in blue, and that particular name is the name of the we can say name of that particular relation. So for example, in the middle of the screen we can see a course which is the course table with course ID, then title, then department name and credits as its fields, where course ID, which is the underlined one, is being shown with the help of which is being shown with the help of underline is the primary key. Now if we want to talk about the foreign key dependency, so from here you can see in this course you can find an arrow which is coming from the prerequisite table lying under this particular course structure, and there is course ID and another field is there. So this course ID is actually a primary key inside the course table, where in prerequisite this is taken as the foreign key. So there is an arrow starting from the course ID of prerequisite table to course ID of your course table. So tail of the arrow we can say is at the foreign key, while the head of the arrow is at the primary key. So we can have a closer look at this. So here the course with course ID, title, department name and credits, while the prerequisite table is having course ID and prerequisite ID. So prerequisite ID will also come from the course ID, and course ID is actually a primary key which is being derived from, is actually a foreign key which is being derived from the course ID of the course table. So in this way here we can show with this was actually a complete schema diagram of that particular university database whose structure we have seen in the form of the text. So here different tables are being, different relations are being represented with the help of boxes, and each and every box is having a name, all the attributes listed inside it, primary key is being shown with the help of underline, and if there are multiple fields which are underlined, then there is, we can say it's a composite primary key. Apart from this is also having a particular arrow starting from foreign key for showing the foreign key dependency. It is taking help of arrows. So all these things we can represent with the help of this concept which is known as schema diagram. All the all the tables along with the name, attribute, foreign key dependency and primary key constraints, while referential integrity constraints cannot be we can say cannot be represented using this schema diagram. Now apart from this, we have till this point we have seen what actually a schema diagram is and how are we going to we can say represent the your structure of the database along with its various tables, then different we can say different fields of it along with some dependencies in the form of a pictorial map. Now we'll look at our different topic which is also very important, which is about the query languages. Now query, the moment I am saying the term query is actually it is putting up a question. So when I am saying query languages, that means there are some languages which are used for querying a database, which are used for retrieving the information from the database. And when we talk about the relational query language, that means these query languages are actually we can say working on the relational models. So basically your relational query languages are the languages in which a user can request information from the database, or more specifically we can say in which a user can request information from the relational model of the database. These are basically actually these are interacting with only with the databases, not with any other components inside or some memory or something of that sort. So basically we can say that these relational query languages sit on a higher level than that of a standard programming language. A standard programming language is having more access to the components and resources of the computer, while your query languages are actually for accessing the data or for accessing the information from the database only. Now these relational query languages can be of two types. One is the procedural and another one is the non-procedural. So as the name indicates, one is kind of asking for a detailed procedure, another one is non-procedural. So in a procedural language, the user will instruct the system to perform a sequence of operations on the database to compute the desired result. So basically user is going to tell the computer two things. One is what is to be done and another one we can say is how is to be done, because your system is being instructed about the about a sequence of operation through which that particular task is, we can say, accomplished. While if we talk about non-procedural languages, the user will only, tell the system that what is to be done. It is not going to tell anything in detail as in, how it is to be done. So basically, a non-procedural language is actually a language in which the user describes the desired information without giving a specific procedure for obtaining that information. In the procedural language, that procedure for obtaining the information also has to be described, while in non-procedural, that procedure is not required to be described. Now coming to examples of these query languages which fall into these categories of either procedural or non-procedural. So we have many. We have relational algebra, we have tuple relational calculus, we have domain relational calculus, we have structured query language which is SQL. All these are examples of query languages, and if we talk about in which particular category these query languages are going to we can say take place. So your relational algebra is actually procedural. That means it is also going to tell the system about the procedure in which the task is to be executed, while the tuple relational calculus, your domain relational calculus, are non-procedural. So relational algebra, which is also our the upcoming topic, is procedural, while the tuple relational calculus and domain relational calculus are actually non-procedural. So basically these query languages are, we can say, these are the fundamental techniques for extracting data from the database. So the main task of query language is about the extraction of data, or we can say the whole management, as in kind of insertion of data is also a component of a query language, or data definition is also a component of a query language. So basically fundamental techniques for accessing and managing the data within the database is your query language, be it procedural or non-procedural. So in this lecture till this point, what we have covered is actually basically we can say two topics. One is what actually query language is, and what type of query these relational query, how many types of relational query languages exist, and before that we have also seen how to represent a database using a schema diagram. Now continuing our topic of query languages, or more specifically we can say relational query languages, let us begin with the relational algebra, which is, I have just told you, it is a procedural query language. Now procedural query language, that means it is a technique, or it is a way in order to extract the data from the database. Also being procedural, it is going to give a step-by-step process to obtain the result of the query, and it uses operators to perform the query. So basically, unlike SQL, in which we are going to write the commands, in our relational algebra, which is a procedural query language, we are going to use operators. We are going to use select operator, we are going to use project operators, and many others. So with the help of these operators, these we can say queries are performed, queries are executed. Now when we talk about these relational operators, so all the procedural relational query languages provides a set of operations. These operations are to be applied either on a single relation, either on a single table, or it could be on a pair of relations. So we can we can say we can take two relations, we can take two tables, and we can join them, or we can find a union of them, or we can find intersection of those two tables, and so on and so forth. So these procedural relational query languages, they provide a set of operational, even all procedural relational query languages provide a set of operations. These set of operations are to be applied to either a single relation or more than one relation, we can say, but the result is always a single relation. Your result is not going to be in the form of multiple relations, and because of this, as we are going to get a relation in the form of the result also, because of this the relational operations can be applied to the result of queries. So, for example, we have executed one query on two tables, and as an output we are going to get the third table, which is our third relation, and we can apply our second query on, or we can apply our next query on that particular third table. So, relational operations can be applied to the result of queries as well as to the given set of relations also. Now, what all relational operators I am talking about? So, basically inside the relational algebra we have the following fundamental relational operations. One is the select operation, then we have project operation, then we have union, then we have set intersection, then set difference, Cartesian product, and rename operation. So, all these 7 operations are very common, which falls under the umbrella of relational operation, and these relational operations we will be covering in detail in our upcoming lectures. In this lecture we have seen about the schema diagrams, and then we have seen what actually query language is, and we have also seen the basics of a procedural query language, which is the relational algebra. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I'll see you in the next lecture. Till then, goodbye. Take care.